Okay. Often, I actually want this vector, not just the length. That's called the vector projection. Instead of the scalar projection, it's the vector projection. Okay. How do I go from just the length to the vector in this direction of that length? How do I turn a length into a vector in a particular direction? We have done this once before. Anybody remember?
Sorry, can you ask the question again?
I've got a length. The length is 11 on 5.
Mm-hmm.
How do I turn that into a vector in the direction of B?
Don't C and B have the same vector? Wait.
B, yeah, good. C and B are in the same direction.
Same direction, that's right.
That was a question.
Kind of. They're in the same direction. How do I get this length into a vector in that direction?
I remember.
It's C, the vector itself. It's going to be what I just did. That's a scalar, and I'm going to multiply that scalar by the vector b hat. Because the vector b hat is a unit vector. The vector b hat is a vector of length 1 in the direction of b, which is also the direction of c. So if I multiply this unit vector by the length of c, I'm going to get a vector in that direction. Yes, Ben?
Are you just showing it in terms of A and B?
Yes.
Okay.
Yes. I want to work out this vector in terms of A and B. So one way to write it is to go get my scalar projection and multiply it by a unit vector in the direction I want. Do you remember doing that once before?
Mm-hmm.
We said we've got a vector, and we go, how do I get a vector in the direction of this other one? I get the unit vector and times it by the scalar length. So I'm just going to get my unit vector in the direction I want and multiply by the length I want, which is the scalar projection. So that's the first formula on the formula sheet and the syllabus for the vector projection. If I do it this way, I'm going to end up calculating the unit vector twice. It's a little bit messy. There is an alternative.
Squared?
Well, I can expand this out a bit, right? Let's see if I can end up with that formula, which your textbook doesn't do, but let's see if we can. This, you'll remember, was A dot B over the length of B. And then I'm multiplying that as it's a scalar by B divided by the length of B. Now, that's A dot B. How have they written that? Divided by B times B. All I've done is move some scalars around. Now here's the trick. These are two vectors in the same direction. So I can even write that as A dot B. I wouldn't do this long way all the time, right? This is mod B cos 0. Because cos 0 is 1, I haven't changed anything. But this is B dot B. And that's the other formula on that syllabus, and your formula sheet. So if you already have a unit vector, this is a great formula to use. If you've just got two vectors A and B, this might be quicker. And I'm going to show you by doing at least this one as a vector projection as well. I'll show you the different ways you can do it. Let me show you. So, let's go back to what we had before. Calculate the vector projection. I think it's time for these. Of A on B from our numbers we had before. So what I want is, I want a vector of this length in the direction of vector B. So what I'm going to do is this, I'm going to go, use the first formula the first time. I'm going to go A dot B hat, because we already calculated that, times B hat. It's not right, it's supposed to be brackets, not lines. A dot B hat times B hat. Because in this case, I already know this. This was 11 on 5, we already worked that out. Times the vector B was 3I hat plus 4J hat. Now in this form, it's very clear, this is a vector in this direction. It's the same direction as B because it's literally a scalar times that. Yes?
Weren't you meant to multiply it by B hat?
Oh, B hat. Correct, which means I have to divide that by 5. Thank you, thank you. I would have had trouble later trying to make it match. Correct. Which is actually 11 on 25. Thank you. That would have been a problem later. Or if you prefer, you could write 33 on 25 I hat plus 44 on 25 J hat. These are the same. But let me show you the other formula to show you the other way to work it out. Suppose I had not already worked this out. If I didn't already know this, I can go straight there from A and B. Or, both my blue pens are bad. Or, I can go with my other formula, yep, A dot B over B dot B times B. So we're just going to go, I'll write it all out this time, you don't necessarily have to. 5I minus J dot 3I plus 4J over 3I plus 4J dot 3I plus 4J times 3I plus 4J. That hat was a bit crooked. Because dot products in component form are pretty easy. 15 take 4. 9 plus 16. Times we already had that answer, so we know we've got the same answer. Does that make sense? You have two methods. So you have a choice. If you already have a unit vector or you've already worked out the scalar projection, you can just multiply by b hat. But if you're starting from scratch and you don't already have all those unit vectors and things, this is probably quicker if you want the vector projection.